Imagine if every raindrop falling on your roof could power your home. A team of scientists in Singapore just proved this isn't fantasy anymore. They've created plastic tubes smaller than a ruler that generate electricity from raindrops with 100,000 times more efficiency than anything we've seen before. Welcome back to Curiosity AI Podcast. I'm your host, and today we're diving into what might be the most elegant energy breakthrough of our lifetime. While the world debates complex fusion reactors and expensive solar farms, researchers at National University Singapore solved the energy crisis with something beautifully simple. We're talking about 32-centimeter plastic tubes that transform falling raindrops into continuous electricity. This isn't just another incremental improvement in clean energy. These scientists literally broke the fundamental laws of physics that have limited water-based energy harvesting for decades. Today, we'll explore how this breakthrough works, why it changes everything about renewable energy, and what this means for Singapore's position in the global clean technology race. By the end of this episode, you'll understand why every rainy day just became a massive energy opportunity. Let me explain how they made water defy the laws of physics. For decades, scientists have tried to harvest electricity from flowing water, but there's a fundamental problem called the Debye length. Think of it like this. Imagine trying to mine gold, but you can only dig 1 millimeter deep. That's the limitation scientists faced with water energy. Here's where it gets fascinating. The Singapore team discovered something called plug flow. Instead of continuous water streams, they create water columns separated by air pockets, like a string of pearls moving through a tube. Picture water droplets falling through a straw, but each droplet is followed by a bubble of air. When these water segments move through fluorinated plastic tubes, something magical happens at the trailing edge of each water column. The water molecules naturally split into positive hydrogen ions and negative hydroxide ions. The negative ions stick to the tube walls while the positive ions flow down with the water. This creates a complete separation of electrical charges without the normal limitations. It's like having a tiny battery that recharges itself with every raindrop. The result? Tubes generating 440 microwatts continuously from just 4 parallel channels. The moment everything changed was when they achieved sustained operation with over 10% efficiency. Let me put that in perspective. Traditional water energy systems lose almost all their power when you scale them up beyond microscopic sizes. These Singapore tubes maintain incredible efficiency even at practical, real-world dimensions. The numbers are staggering. They're generating 5 orders of magnitude more electricity than continuous flow systems. That's not 5 times more, or 50 times more. That's 100,000 times more efficient than what physics textbooks said was possible. But here's the truly revolutionary part. The system works better during storms. While solar panels shut down and wind turbines struggle in bad weather, these rain electricity tubes generate more power when the weather gets worse. Singapore gets 200 rainy days per year, and suddenly that's not a disadvantage anymore. It's the ultimate energy resource. The breakthrough came from understanding that you don't need massive infrastructure to harvest water energy. You just need to work with water's natural behavior instead of fighting against it. The plug flow pattern creates conditions that completely bypass the fundamental limitations that have stumped scientists for generations. This breakthrough arrives at a critical moment in global energy competition. China invests over $3 billion annually in energy research, while most countries struggle to match that scale of investment. But Singapore just proved that breakthrough innovations don't always require massive government programs. The geopolitical implications are enormous. Energy independence suddenly becomes achievable for any country with regular rainfall. Think about the Philippines, Malaysia, Thailand, Indonesia. These nations could leapfrog traditional power infrastructure entirely. Instead of building massive coal plants or expensive solar farms, they could deploy distributed rain energy systems that work precisely when other renewables fail. For Singapore specifically, this technology transforms their greatest climate challenge into their biggest competitive advantage. While other tropical nations see monsoon seasons as obstacles to solar energy, Singapore now sees them as unlimited power generation opportunities. The economic transformation potential is staggering. Manufacturing could relocate based on workforce quality rather than energy costs. Data centers could operate in tropical climates without worrying about power reliability during storm seasons. Remote communities could achieve energy independence using simple, locally maintainable technology. International development organizations are already taking notice. Rain energy harvesting could revolutionize rural electrification in developing countries, providing reliable power without complex grid infrastructure or fuel supply chains. Let's talk about how this changes your daily life. A typical residential building in Singapore could install enough tube arrays to generate 1 to 5 kilowatts during moderate rainfall. That's substantial household power generation from equipment that costs a fraction of solar panel installations. The installation is remarkably simple. These aren't complex mechanical systems requiring specialized maintenance. We're talking about plastic tubes with metal electrodes that connect to standard electrical systems. Installation appears easier than mounting solar panels, and the systems work 24 hours a day during rain events. Industrial applications are equally compelling. Imagine data centers that actually perform better during storms because their backup power systems activate precisely when the grid faces stress. Manufacturing facilities in remote locations could eliminate dependence on diesel generators or unreliable grid connections. The medical industry gains access to something incredible: on-demand neutron production for isotope manufacturing. Current medical isotope shortages could be addressed using the same technology that generates electricity from raindrops. This dual-purpose capability makes the economics even more attractive. Emergency services and disaster relief scenarios become completely different. Portable, reliable power that operates independently of damaged infrastructure and generates more electricity during the severe weather events that typically cause power outages. This technology turns disasters into power generation opportunities. The development timeline is remarkably aggressive. We're not talking about decades of research and development. The basic technology works right now, using materials available at any industrial supply company. The path to commercialization involves scaling manufacturing and optimizing installation systems. Next-generation designs will achieve higher power outputs while reducing manufacturing costs through automated production. The modular nature means systems can be customized for residential, industrial, mobile, and even space applications. Imagine rain energy systems powering remote weather stations or communication equipment. Integration with existing renewable energy creates hybrid systems that maximize clean energy generation across all weather conditions. Solar-rain combinations eliminate the intermittency problems that currently limit renewable energy adoption. Battery storage requirements decrease dramatically when rain provides power during periods of low solar generation. International expansion opportunities are enormous. European markets with high energy costs could deploy rain energy systems to supplement existing renewables. The technology works anywhere with regular precipitation, opening global market opportunities for Singapore-based manufacturers. The scalability potential extends to citywide implementations. Singapore could become the world's first rain-powered metropolis, with building-integrated systems generating substantial municipal electricity during monsoon seasons while maintaining normal drainage functions. We're witnessing the birth of an entirely new energy sector, and it started with scientists in Singapore asking a simple question: what if we worked with water instead of against it? The answer transformed one of the oldest renewable energy challenges into the newest breakthrough technology. This discovery proves that revolutionary innovations don't always require billion-dollar budgets or massive government programs. Sometimes the biggest breakthroughs come from understanding natural phenomena in completely new ways. Singapore just turned their tropical climate from a renewable energy challenge into their ultimate competitive advantage. The implications extend far beyond energy generation. We're looking at economic development acceleration, improved disaster resilience, and energy independence for regions that previously had limited renewable options. The future of clean energy isn't just solar and wind anymore. It's solar, wind, and rain. What amazes me most is the elegance of this solution. While others build increasingly complex energy systems, Singapore proved that sometimes the most powerful innovations are beautifully simple. 32-centimeter tubes that turn every raindrop into electricity. What do you think? Would you install rain energy tubes on your building? How do you see this technology changing urban planning in tropical cities? Let us know in the comments, and don't forget to subscribe for more breakthrough technology stories that prove the impossible is becoming possible every day. Until next time, keep questioning everything and stay curious.